So, our first unit is on real numbers. And the essential question is what types of numbers are there and how do they relate to each other? So, a lot of this unit is taking what you already know and just going a little bit deeper into it. So, you might feel sometimes like, well, you learned this in fifth grade. But remember that we will always take it and add on to it the eighth grade objectives. So to start, what types of numbers do we already know? Well, we know, the most common you might think of are fractions and decimals. So, and then we've got square roots and negative numbers and percentages and whole numbers and integers. So all of those are different types of numbers, and we're going to add on to our knowledge about numbers and also learn more about some of those as well in this unit. And so the very first section is rational and irrational numbers. And again, we'll learn more about what those words mean towards the end of the unit. But we're going to start with part one, which is just looking at fractions and decimals. And so our two objectives is one, given a fraction, I can write an equivalent decimal. In other words, I can turn a fraction into a decimal. And in the other way, I'm going to take out some of the wording to make it simpler for a minute. So given a decimal, I can write an equivalent fraction. So basically, I can turn a decimal into a fraction, and I can turn a fraction into a decimal. What makes this an eighth grade standard is we add in that including a repeating decimal, which is what we're going to focus on today. To turn a fraction into a decimal, you just take this and you read it 1 divided by 8. So always think of this as the operation of division, and we just set it up 1 divided by 8. And then we just start dividing. 8 doesn't go into 1, so I have to add my decimal and a placeholder. So 8 goes into 10 once. And then we keep going until either we see that it's repeating or we stop. So 8 goes into 20 twice, which would be 16. Add another 0. And in this case, 8 goes into 40 exactly 5 times. And so I can be done. And so my final answer would be 0.125. Probably better to write the 0 right in front, so 0.125. So let's try a couple. Turn the fraction 2/5 into a decimal. We just divide, so we set it up 2 divided by 5, and 2 goes into 20 4 times, and we're done. So my answer would be 0.4. Now, use a calculator for this one. Just really quickly turn 1/9, 2/9, and 3/9 all into decimals and tell me what you notice. So each of these becomes a repeating decimal, and notice that the number that's repeating is the number that's in front of this. So based on this pattern, if I was to turn this decimal, 0.4 repeating, into a fraction, what do you think you would get? Yep, that would be 4/9. And the pattern does continue. 5 repeating would be 5/9, and so on. Now, the question though then becomes, what about fractions like 1/3? Now, we know if you were to turn this into a decimal, what would you get? You would get 0.3 repeating. So how come that is repeating and it's not over 9? So think about what that would be. It would be 3/9, which then simplifies to 1/3. Using a calculator, can you turn 1/11 into a decimal? You should have gotten 0.09 repeating. So think about our rule. The part that's repeating is 0.9, or just 9, Now, if I write it over 9, it's going to become 1. What do you think I'm going to write it over? Yep, I'm going to write it over 99. Because there are 2 numbers repeating, I write it over 2 9s. And then if I was to simplify this, it would go right back to 1/11. So write 31 hundredths repeating as a fraction. Yep, it would be 31 over 99. And then how about 0.8 repeating? That would be 8 over 9. How about 0.235? All of that repeating. Yep. It would be 235 over 999. Again, remember to simplify these if you need to. So here's a challenge, and this is for anyone who wants the extra challenge or to my honors math kiddos. So with this, notice the difference is that I only have 2 numbers that are repeating, not the whole piece. So this requires quite a different approach. I can't just write it over 99 because if you were to test that, it would not work. So what I'm going to do is I'm actually going to use equations to solve it. I'm going to write this as x equals 0.235 with the 3/5 repeating, and then I'm going to multiply both sides by 100. So I'm going to multiply the whole piece, each side by 100, and I'll get 100x equals, this just moves the decimal point 2 over, so we get 23.5, but remember the 3/5 is repeating, so I'll write that one more time. Now I chose 100 because there's 2 numbers repeating. If there were 3 numbers, like if this was 1, 3, 5, 7, and there were 3 numbers repeating, I would multiply it by 1,000. If there was 1 number repeating, what do you think I would multiply it over? Exactly, I would multiply it by 10. So back to this. Now I am going to subtract the original piece. So I'm going to actually subtract this. So I'm going to subtract the x on this side, and I'm going to subtract the 0.235 repeating. Remember, that's the repeating piece from this side. And what that does is that actually gets rid of all the repeating, because they all, if I was to just keep adding them here, they're all being subtracted out. So what I get is 99x equals 23.3, and it's done. It terminates or it ends. And then to solve that, think back to last year, we divide each side by 99. So my sort of final answer is 23.3 over 99. But again, that doesn't look right because of that decimal. So what I have to do is I have to multiply both the top and bottom by 10 to get rid of the decimal. So we would get 233 over 990. So one suggestion is to go back and write down the notes from that last example and use it to solve this one. So try this one on your own. So with this one, I'm going to multiply it again. Well, actually, we're going to first set it equal to x. Multiply the whole thing by 100. So we'll get 100x equals 46.767. Again, that 67 is repeating. Then we subtract this piece, so we subtract x, and we subtract 0.467. Again, the beauty of this is that this now, the repeating part is gone. So we get 99x equals 46.3. And then we divide by 99. So x equals 46.3 over 99. But again, it doesn't look right because of that decimal, so we're going to multiply it by 10 over 10. and we'll get 463 over 990. Sometimes you will get decimals that are repeating where there is a number that's part of it that's not decimal. So, for example, 2.13, where the 1 and 3 are repeating. All you need to do on that is leave that 2 out front of your fraction and write it as 13 over 99. And sometimes the answer will be in an improper fraction. So remember to turn that into an improper fraction. You would multiply 99 times 2 and then add 13. So 99 times 2 is 198 plus 13. And again, write it all over 99. And that would be 211 over 99. So let's try one of these. So let's try 5.71 with the 7-1 repeating. And this would be 5 and 71 over 99. How about turn this one into an improper fraction? So it would be 5.4 repeating. And that would be 5 and 4/9, or 9 times 5 is 45, plus 4 is 49 over 9.